Today we're looking at another Dyson fan. Now this is a Dyson hot and cold version, which I purchased on eBay for spares or repair, and apparently it's just dead. So we shall switch it on and we'll try the power button, and it looks like they are correct. It doesn't seem to be doing anything. Right. Now I think what I'll do, I'll take it downstairs on the bench, but it still might be slightly large to fit on the bench. So I might remove the top loop first and then we'll investigate what's going on in the bottom of it. I'm going to use a little screwdriver and just remove this little tab thing here, if I can figure out how it comes out. And here we go. Right, and we've got a small Torx. Now on the last one, this did a sort of half turn like that, and then it came off. Right, this one, the heater must be in the top, because it has some wires connected there. So I think what we'll do, we'll disconnect these wires first. So I don't think the problem's going to be in that part. So, right, I'll just pause the video a sec, I'll remove these wires and then we'll continue. Right, well that was a job to get off. It was a lot harder than I expected. These spade connectors, they've got like a little locking tab at the bottom of them. So you need to get a screwdriver in and press the little locking tab in. And then there's a little pin goes in this hole. So when you press the tab in, it pushes the little pin, securing pin, back. And then you can withdraw the connector. But yeah, that was a bit not easy to say the least. So, and it's the same with this one. It'd be better to start on this one here, because actually you can see there on this one, you can see the sort of locking tab. So when you press that in, it like I say, it withdraws the little sort of thing that's sticking out, and then you can pull the spade connector out. Right, so that's the top off, so it's a little bit easier to manage now. Right, I think we'll start with the very bottom of this, because I don't think it'll be the motor. I think, well, it could be the motor still as well, but I think there's obviously a problem with the power. I'll tell you what, one thing we didn't check, that's one if the fuse is alright. It's a 13 amp fuse, so if it has gone, there's definitely some something gone seriously wrong. Let's just have a check of this fuse. Yeah, first thing to check would have been the fuse, wouldn't it? I'm still getting used to this meter yet. Right. Yeah, fuse is okay. Okay, now how does this come off? That's it. Right, so let's put this base to one side and we'll remove these screws here by the look of it. Might have to take them two out as well. Nice. Now I wonder if this is a similar. I just noticed that this little retainer clip here looks slightly bent, as if somebody's had that off before. Right, bigger Torx. Slightly different design to the other fan I looked at. Can I lift that over maybe? Oh, maybe a bit. Oh, actually, just move it a bit there. So I've got holes here, and I can see some plastic thing there which looks like it holds this base on. Because we can't power it up, I can't get the motor to turn. I can get that over there like that. Alright, okay, here we go. Right, so it looks like there's little screws down here hold these little plastic clips on, which in turn hold the bottom on. This looks like it's going to be fun to put back together. Just tighten those back up so we don't lose them. Right, so what do we have? It doesn't actually look like there's a lot in here. Ah, there's the main control board and that and stuff down there. Right. Now, what's this down here? Is that something blown? Right, yes. I see signs of something blown up down the bottom here. Round about on the power input board, round about here. So I'm going to remove this bit of plastic here. And then we'll see if we can get this main board out, or mains board. I think I might have to take that, get this bit of plastic out of the way. Yeah, that doesn't look good. I'm just looking at the big black mark around about under here. If you can see that. Yeah, definitely looks like it kind of blew up in a big way. Now, does this unplug? Yes. Right, so that's the motor board. Sorry, the oscillation motor. Right, I'll have to take this bit of connector off as well, this bit of plastic, sorry. And if I disconnect those black, and I bet these have got these these little grippy connectors on as well. Actually no, I might be wrong. Actually, if I take that one off, I've got the whole board out then. Right. I'll put that to one side and let's have a look at what we've got going on with this. So we have a rather large chip there with a number 2 on it. I suspect that is a motor driver IC. Looks like we've got a small microcontroller here. We've got a bridge rectifier. Oh, somebody's had a go at soldering on this as well. Right, looks like there's a track blown to the neutral side of things. So if I just bring this a little bit closer so you can see. That's from here to here. There should be a track. But it looks like somebody's had a go at this. And there's definitely quite a bit of black on the top here. I'm not sure if that's an exploded metal oxide varistor or not. Okay. Nice. Anyway, we'll check some of these diodes here because that might give a bit of an indication of how far the problem's gone. Is that the main capacitor there? Right, well that doesn't look good. Because I don't think we should have that low of a resistance across there. I don't know if any of these diodes have gone. See, because it's got the conformal coating on, it's a bit hard to actually get the probes on. Well, that one's okay. That one's okay. That one's okay. That one's okay. Actually mightn't be as bad as I thought. Let's see if this one. That one's okay. So the bridge rectifier diodes seem alright. I guess that. Yeah, it looks like they're using one of those opto isolator triac drivers again to control the oscillation motor, because that's similar to what was in the last unit that I looked at. I think I might remove this this little choke here just so we can get a bit better look at what's going on under this circuit board. Apply a bit fresh solder first. Well, normally when you get damage like this, it's an indication that something has failed further on in the circuit. So I think it would just be pointless repairing the track because it would probably just blow up again straight away. Right, try a solder sucker on those. Well, that actually looks alright. Right, we'll get a bit IP on this and we'll give it a clean up. That's the only thing when somebody has had a look at stuff before, you don't know what they've done, what they've replaced, or... I don't know if that's a big resistor there that's blown as well, because I can't see any markings on it now. There's a resistor there marked R53, which I'm not sure whether that feeds the motor driver chip. I don't know if that's some damage there as well. I'm just looking on these little pins here. Just there. I'm not sure if there's a bit black there as well. So I wonder if the motor driver chip has failed. Right, I've just had a quick look over the board with the magnifying glass just to see if I could see anything obvious, and yes, that track going to the motor driver IC has definitely blown. So then I started having a bit closer look at the motor driver IC itself, and if you look just down here, you can see a crack there, obviously where it's exploded. And if you notice just here, I'll try and get it in focus, there's a crack here as well. It's like a very fine one. So I think what's happened with this is the motor driver chip has failed. It's gone short circuit, and then it's blown the track here, and obviously the track here. Now I don't know whether it's caused any other damage, whether it's because potentially actually that resistor seems to be blown as well, which is probably just like a safety resistor, just to you know, if this does happen, it's supposed to blow, but obviously it blew as well. Now whether or not the microcontroller's blown or whatever as well, I'm not 100%, but yeah, that chip's definitely gone. Now the problem we've got is it's just got a number 2 on it. It doesn't actually have a part number on it. So whether or not this is a component that Dyson's had specially made, which I doubt it, more than likely I would think it's the motor driver chip that's just been rebranded and had a number 2 put on it for Dyson. So I'll investigate to see whether we can find a replacement chip, or whether it's beyond repair, because like I said, it may have also blown the microcontroller if it's fed back through the circuits with the motor driver chip shorting out. Right, so I'll have to do some investigating and then we'll continue from there. Well, we have a little bit of an update with the Dyson fan, and we have some good news and some bad news. Well, the good news is I've managed to remove the motor controller IC, and it has a number on. So this is an SMA6822M. Now I did a quick search on these, and you can buy them. They're about £8 each, so not the end of the world. So that's the good news. Now for the bad news. This microcontroller here, which is a Renesas, is it? Renesas? I'm probably pronouncing that totally wrong. Renesas, I think it's called. It's an R5F212L, if I remember. And if we measure the capacitor, that's just on the VCC and ground, which is just here, and we'll get about 8 ohms, which doesn't seem right across the supply of a microcontroller. So I'll bring the microscope in and we'll investigate a little bit further. Right, so this is the microcontroller here, and that's the resistor that we're measuring the 7 or 8 ohms or whatever on. Now if we come across here, we'll notice there's a resistor here. It's got a bit of a burn mark in the centre of it, and there's another one here, and there's another one here. Well, all three of those come from the motor driver chip here, and they all go back down these tracks here into the microcontroller. So what it seems that's happened is the motor controller IC here, when it's blown short circuit, some of the high voltage is fed back through these resistors here and into the microcontroller and fried it. Now, we could probably buy one of these microcontrollers, but the problem is it contains code which we don't have, so we can't reprogram it to make it work. So I don't think we're going to be able to repair this one. And to make matters worse as well, it seems that Dyson have actually discontinued this model and you can't buy the boards anymore. Right, we'll pull the microscope back out the way. So yeah, so unfortunately, like I say, I think this one's just going to have to go into the parts bin for now. And at some point I might get a replacement board for it, or I'll get another unit and use this one for spares. So unfortunately, no fix on this one, guys, but we'll give it a go. Right, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comments section below. And as always, have a great day. Thanks for watching.